So I'm handing the camera here off to Lisa because Lisa's going to be our camera person.
When does it start recording?
It is recording.
Oh.
All right, we're playing a game. I'm going to give you're a lucky winner. You get to play a game where we're going to throw things on the floor out by the public safety desk. And what we're going to do is you win a prize depending on what it lands on. The pattern on the floor out there. Out there are these beige tiles. I'm terrible at colors that weren't in the box when I was 8. But I think that color is called beige. There's brown and there's green tiles. Lisa, why are you got the giggles? Who are you staring at? Are you zooming in on somebody or something? Don't do that.
Okay, I won't.
Alright. So here's the deal. I will pretend that we're giving you $1 for every time you land or throw these dice. Because I have things that throw. And we're going to be throwing. So, oh hell, let's have a field trip. Come with me. We're going out by the public safety desk up there. Hi, here, come with us. We're going on a field trip.
This is what I do in the morning.
Okay.
All right.
Oh, I need to
See, you have points here. You're going to have a class so great that it's going to be great. All right. So the game is you've got a dice, and you win a big prize depending on what. We're just having a little class out here on the floor because we don't make too much noise in the classroom. So you throw a dice, and whatever color of tile it lands on, you win that prize. So if it had landed on one of these beige tiles, you win $1. If it lands on one of these brown tiles, like it just did, you win $2. And if it lands on one of the greenish tiles, you win $5. Okay? So it's like a little game. Now, first off, a perfectly reasonable thing to want to know is what should you expect? I mean, there's a lot of those beige tiles around here. So you might be getting, there's a lot of places where you throw the dice and you're going to get $1. There's a lot of places on the floor that are that brown color. And they are, you're going to win $2 on that. Now, there aren't there very many of these green places on here where you're going to win the $5. So, figuring out, what do you expect? I mean, you're going to get about $1. Is it going to be between $1 or $2? Is it going to be more like $5? Well, there's a couple of ways we could think this through, or we could use the technique that we did the other day in class, where we just tried it. Because, I got 30 dice right here, and a bunch of labor. Who's got a notebook with them? Anybody got paper with them? Go get paper real quick, MJ. MJ's going to be our data recorder. And we only need one data recorder, one videotaper, and a whole bunch of people to fetch dice.
Yes.
Because let's face it, things are going to go nuts, right? Yeah. We started with 30 dice. I don't have any idea what the odds are we're going to have 30 dice by the end of the day. But once we get going on this, we're going to dump them and see where they go, and MJ's going to keep track of how often we dump the 30. We'll do it a couple times so we have some data, right? Maybe we'll dump it 10 times. So we'll have 30 times of throwing the dice. 30 dice, 10 times, we'll have 300 throws. So you're our data recorder, okay? Everybody else is a fetcher.
Yay.
Okay? So you're going to write down, after we dump 30 dice on the floor, how many landed on beige. Are we in agreement that this color is called beige?
Yes.
Close enough? We're going to call this color brown, and we'll call this color green. All right? I'm going to dump them, and the other 4 are going to fetch while you videotape. Okay? All right. Oh, it's so much worse than I thought. It's so much worse than I thought. All right, go fetch them and keep track of how many were each place.
Beige, brown.
We're keeping track.
Here, we're gonna
Manual labor.
yeah, whatever
Sister
it takes.
Scary.
That data recorder.
I'm just gonna stand there. Yeah, that's my job. There's one over here, by the way. Look, everyone.
Oh, you're closer putting it here as you go.
I don't know how.
Call that one beige.
Please tell me you guys kept track.
Yeah.
Yes, so,
6 beige,
all right, so
4
how many
brown.
landed on beige? Give that information to MJ.
6 beige. Okay, hold on. Malia has 6
There's
beige.
no way we're getting
7 on brown. 5, 6. Okay, what did you have?
4 brown. 2 beige, 1 green.
2, 3, 4. 1 green. Did you say 6 beige?
Did I? Yeah.
Okay. Yeah, and 7 brown. 1, 2.
I knew they would really bounce on the tiles. This is
Okay,
gonna be a
did
fun
you say
game.
7 brown? Yeah.
We're gonna do that 10 times.
Oh, we won't do it 10 times, it's gonna take too long. Maybe we'll do it 4 or 5. Just so we have a pile of data.
3 brown.
Just a couple.
Come on, how many times do you gonna make a mess like this in a math class?
Okay.
Not many. All right, so what did we get, just out of curiosity?
Okay, so for beige we had 14 beige,
Okay,
14 brown, and 2 green.
okay, perfect. So at least at that point, we still had them all. Okay, we're gonna do it again, ready?
Not any of them have been lost yet.
that one was even worse.
Here, I'm gonna keep these little.
I feel like doing it like this is the only way to do it.
You just
There's
gotta
another one over here on beige.
dice.
Yeah.
There's another one over here on.
Beat a dice.
Beat the dice. I'll sit over here.
There's no way I'm getting all 30 of my dice back after this game. Let me tell you.
Good job, Andrew.
Thank you.
Yeah.
Don't lose any.
I think I have 2 beige, 1 brown, 3 green. Okay, 2 beige, 1 brown, 3 green. Yeah.
So far.
Trippy.
You say 2 brown? Yes. Okay. How many beige again? 1. Okay.
I don't know what count. It don't matter. If they're gone, they're gone. I don't know where to do them.
They're gone, they're gone.
Maybe that will turn into our assignment.
Is there 30 of them?
Just
What?
Is there
I
30
didn't
still?
count.
I'd have so much money right now.
Yo, because the game is great, right? I didn't make any way that you could lose money. I should have made it that like the beige you lost money, but whatever.
You should have made these like $20.
Yeah.
These like $5, and that's
I'm
like
glad
minus
that
10.
you have a sense that we should have changed the rules of the game, because guess what you're going to be doing in your assignment. All right, so did we have...
Changing
The rules.
Okay, fantastic. All right, just so they don't scatter so much, I'm going to kind of toss them more this way this time. All right, just so they don't go so crazy.
That was a little bit better,
Yeah.
I guess.
I'm gonna count that as a green. I'm gonna start putting them on the line below, so that way.
It'll be interesting. Yeah.
There she goes.
I'm doing the miracle amount of work.
Anybody else got any?
Huh?
You having fun?
Yes.
Yeah, it's fun. It's fun to be the camera person.
Addiction is.
All right.
I watch a lot of YouTube, so this is like
You
my
watch a lot of
yes,
YouTube.
like Vlog Squad, and like
Like what?
the Vlog Squad. Do you know who that is? David
No.
Dobrik, Karina Koff,
Squad.
Scotty, Todd.
That's funny.
You don't know who they are? Liza Koshy.
I know.
As I watch them all
All right.
the time.
We still have all 30. That's amazing. Okay, we'll do one more spill of them. All right, here we go.
Surprisingly, the more that's coming out is brown, not beige.
Really? I wonder why you said surprisingly.
Well, I was thinking because.
Do you have a sense that there's more beige than brown?
No, I was just thinking because like those, like the tiles just look to be a little bit bigger, but like looking at it, these are more. They're long.
MJ has just had a very important intuition,
Okay.
which we will be talking about shortly. And more? Anybody else got any over here? Real quick.
Those dice moving around is like ASMR. You know what that is?
No.
It's like whenever you like clink on the mic, it's like.
It's like whenever like sound.
Oh, really? That's
like
interesting.
it-
Just out of curiosity, can you count them and make sure we say
That's probably gonna be terrible
Not the time or place.
for
Still all
ASMR.
30. That's interesting.
This
Okay.
lady walked by and I zoomed in on her
Four
face.
rolls of it will be enough for what we're doing. Okay, so one way that we could have decided what we were expecting to happen would be just to try it a bunch of times. We just threw 120 dice, and we will be tabulating. Just out of curiosity, you did them as tally marks. How many beiges did we end up with?
Okay, like in total.
Yeah, if you can, real quick.
Biohazard materials. So I basically.
60. You got 60 a beige?
Yeah,
That's awesome.
just
And
I'll
how
post
many
it.
green? How many greens did you get?
I know, well, they put it in
50.
fine.
9. Okay. All right.
Surprising.
Wow, that worked out really well. Okay, so here's the deal. MJ had an intuition there. She said, obviously, the size of the tiles have something to do with this. I mean, clearly there is less green on this floor than there is brown and beige. And actually, you might get a sense that there's less brown than beige. Now, in case you haven't figured out, I got like a weird brain. And this floor drives me nuts. Because I'm always thinking through as to like what fraction of the floor is green? What fraction of the floor is beige? And what fraction of the floor is brown? Do you have any sense, Luke, as to how much is which? Is there more brown than beige?
There it is 1/20th green.
Oh, you say 1/20th.
Boom.
I think if we calculated up the surface area,
Boom.
it's like the size
Wow.
of one
I just
green
lied,
tile is
1/16.
the same as one brown tile, but these aren't equal to
Yes,
this.
but can we agree?
Okay, but
that, like,
this
if
is
we
worth.
ignored these beige tiles and just divided them up like they were the other tiles, we'd have 9 beige tiles right here.
These 6 of these are worth
No, not 6.
this.
Here's the deal. I think, let me get on the floor. I think these beige tiles, if we just got rid of these lines and put the lines this way instead, we'd have 9 beige tiles here, right? Are we in agreement there'd be 9 beige tiles here, right?
Yes.
Yes.
There would be 9 beige, and then the pattern goes over here, and there are, you knew this was going to come to this, and there are 8 brown tiles, and there's 1 green tile. And then it repeats, right? So there is 18 tiles to the pattern if we pretended that these were, 9 little ones instead. There would be 18 tiles, 9 and 8 and 1. 1/18 of the pattern is green. 1/18 of the pattern is green. 9/18 of the pattern is beige, or 1/2. And 8/18 of the pattern is brown. By the way, did you notice? 1/2 then of the floor is beige. How many of the 120 dice did we get landing on beige? 60. 60 of 120 landed on beige.
That is.
I don't like this math.
Okay, so now here's the deal. We did this by throwing dice, and it all worked. But now we're going to go back to the classroom and find out we could have done this using math. Okay, and we're going to see how close the numbers we got came to what the math tells us. Because we're still not quite sure. I mean, look, MJ could have then figured out 60 times we got $1. 21 times I think it works out to. No, 51 times you got brown, so you got $2. And 9 times you got green, so you got $5. And she could add it all up and divide by 120 and find out the average amount we would have won, right? That would be a way to do it. Maybe we'll even do that. But first let's find out how to do it just using the
But.
math. All right, back to the classroom.
Aw.
What happened?
These are my
Yeah,
Vlog
60.
Squad days
No,
are
you're kidding,
over.
we didn't lose
I'm
any.
living my true dream.
All right. Let's go back to the classroom and do this with the math.
Yeah, this is actually
that was-
this is so much fun.
That was fun.
I actually want to get a camera and start recording my life. Would you guys watch?
This is how I watch it.
You guys would subscribe?
$207.
Like, comment, subscribe.
We made
ring that
$207.
bell. You gotta have a sign off for this when you're done.
Oh. I don't know.
I'm
Like,
starting the YouTube channel where I just do our math homework. Or not.
Hey, why don't we all make a collective, just study account on YouTube? And it's just us
That'd be
crying.
awesome. Okay, so we can switch the camera now. It's on the tripod, so that you don't need that anymore because we're just gonna be at the board for a while. All right.
Subscribe to my cat YouTube whenever I make it.
Your cat YouTube?
Yeah,
Subscribe to my study
I made an executive decision to YouTube.
Wow.
And it will be just like, enjoy my life.
We were talking about that the other day. Well, I guess it's been a couple weeks ago now in pre-calc that they were shocked that they did a little googling and realized that I've got a couple hundred followers of my channel. They're like, yeah, I'm totally shocked by that myself. Okay, so here's
Are
the
you
deal.
going to do a giveaway? A face reveal?
Anyway, no, I'm not giving a giveaway. Oh, look at a box. We're gonna give a sample box. Okay, so here's the deal. Here was the game we were playing. Remember, land on the beige, you get $1. Land on the brown, you get $2. Land on the green, you get $5. And you'll notice that even before we were out there, I had already counted the tiles because that's what I do, Malia. And I already knew that the answer is that half of the floor, 9/18 of it, is beige, and 8/18 of the floor is brown, and 1/18 of the floor is green. So we should be able to do the math and figure out what we expect, and that is a thing in statistics. That's called the expected value, which is the topic of today's class. In this case, just to use a little power vocabulary here, the amount of money that you would win each time. Hello.
Hey, Mr. Shaggy.
We are taking a pop quiz in the class today.
Okay.
And rather than have one person take the pop quiz early, I will send you the pop quiz and you just take it late. Okay, so like if you got time this afternoon or something like that, take the pop quiz, and then we're just going to go over the pop quiz. That's all we're doing today. It isn't really pop. I mean, I just don't have an entry in the grade book for something. Quizzes they knew were coming. So, all right. So you don't have to worry about like any homework or anything this time.
All right.
Also, we're not going to look at
There won't be homework. They're just going to be getting ready for the test, which is next week.
don't care about getting ready for this.
I don't care about
Oh,
getting
and-
the test. All right. So you got some homework for me?
Yeah, I did all the ones that I could. Can
All
I
right.
come in?
Yeah. Please do come in sometime today. Okay.
Monday.
Monday? Perfect. That'll be fine.
Okay.
Okay. I want to see it. All right. We're playing games today in finite math over here, so.
Yeah, we're gambling again.
Let me go ahead, though, and show you a vocabulary word here. This value that we assign to each outcome is called the random variable. That terminology is sort of hard to define. Your book has a definition in there that I like. But think about it. That's like the value you are assigning to a particular outcome. Like in one of the things you're going to be doing on the exit ticket today, like the outcome of buying the lottery ticket. You have a very large probability that the outcome is 0, and a very small probability that the outcome is 1,000,000. The outcome, though, is the random variable. You either got 0 or you got $100 million, right? All right, in the same sort of way, the random variable here is 1, 2, or 5. It's the outcome of it. And we should have some expectation of what that's going to be. There should be some weird chance that it will, there's some chance. If I pick people in this room, if I just randomly pick somebody in the room, there's a 1/6 chance I took Lisa, there's a 1/6 chance I took Andrew, there's a 1/6 chance I took Luke, and they're all different heights. There's 6 people in, well, 6 students in this room. Okay? And so, and each of them is, say, a different height. But there should be some expected value of what a height I'll get of the, and somebody says, well, what are you expecting to get as a height when I pick a student at random? See, there should be some, there's an intuition here that this means something, right? There's a sense of what this means, and in fact, there is an expected value, which is E. And all E is just the probability that the first outcome happens times the value you give that outcome, plus the probability of the second outcome times the value you give that outcome, and so on through all of the possible outcomes. So in this case, for example, from our game that we were playing out there, there was a 9/18 chance you'd get $1, a 8/18 chance that you'd get $2, and a 1/18 chance you'd get $5. Does anybody happen to have a calculator handy? I didn't actually do the math of this. I very rarely can say that I did not do the math of this. But whatever, you can do it real quick. And this is the expectation.
Would it be 30 over 18?
What, the whole sum?
Yeah.
Well, let's see, it's 9 plus 16 plus 5
I think it's 30
over
over 18.
18. 25, 30 over 18, that sounds right, which is, I don't know, whatever it is. It's a little less than 2. Lisa wins the prize. She wins a gold star for the day for having seen that pattern. Yes.
She gets a gold star and 100 subscribers.
And 100 subscribers to her YouTube channel.
I would love 100 subscribers.
And, well, I can tell you it's not that exciting.
I watch so much YouTube, I would love to be part of it.
Do you watch my YouTube?
Your videos on YouTube?
Yeah.
The lecture-
The weather ones?
I watched the lecture videos for this class.
Oh,
Can we?
They're boring.
Can we seriously make like a fandom for?
Yeah,
just
what's
showing
your
these?
favorite?
I had a bunch of people subscribe to me yesterday. Where the hell did that come from? I don't even teach those classes anymore. Anyway, yeah, so anyway.
You should call your subscribers like clouds. Like
I'm like right around 700. I think it's 750 you have to have in order to start monetizing it. I'm thinking about turning on the monetizing.
Monetize whatever.
Because yeah, you have to have 750, I think it is. At least it used to be 750. Maybe
Take
it's
to
not.
receive money.
We call ourselves the Cloudy Boys.
That's right. I'll have you guys subscribe, then I'll be able to monetize it. No, anyway, I haven't actually looked at my statistics.
Okay,
I don't actually know how many actual views. I used to have a lot of views, but I don't know. I have
Get
any
like
Create a Patreon.
50 cents a video.
Patreon. All right. Anyway, the point is, somebody did the math and it worked out to a little bit less than 2, right?
1.66.
1.66
Or
is
what's
not. No, that can't be right, is it?
Did I do it wrong? 1.67?
Is it? What is 30 divided by 18?
500 subscriber live stream. Sorry, that's a lot.
1 2/3.
1 2/3. Okay, whatever. That's okay. That is what Luke had then. Okay. So, all right. Let me just double check here as to what my phone is beeping at me. Make sure that isn't Shelby saying the bus didn't come or something like that for my kid.
Okay, which one is your account? The one of you holding your son up, or the one just holding your son? Is it the one with 665 subscribers?
The one with 600. I don't think 660. Somebody must have unsubscribed. That's interesting. Okay. Anyway, those are all meteorology videos. So you know whatever. Anyway.
Subscribing to both.
Oh my God. All right. Anyway, so the expected value on a typical roll, you're never going to get 1 2/3 dollars. That's not a real outcome, right? But on average, sometimes you get $1, sometimes you get $2. Once in a while, you can get $5. On average, you would get 1 2/3 dollars, which is awesome. This is a great way to solve certain kinds of problems, where you're just wanting to know what can you expect. Okay. If I wanted to pick the average height of an EDSC kid, what could I expect? What's the probability? Well, you might know things like 2% of the kids are in this are between 4'1" and 4'2", and 3% of the kids are between 4'2" and 4'3", and you could just with little kids.
Yeah, that's
Okay.
true.
All right, so you could add up all the probabilities times each of the heights, and you could find out the expected value. I just pull a kid out of EBSC. What's his height? Okay, what's the average kid's height? This is a great way to solve problems, but it's especially a great way to solve games. And so we're going to talk about games for the rest of the day, because games are fun. We're going to break up into 2 groups, because there's 2 different games going on out here. 2 different things going on, rather. Okay. The first group, we'll call them the people on the south side of the road. What is it? What's all that noise?
I don't understand.
Hold on.
That's all I heard too. What was that?
Was it me?
Oh, I'm sorry.
Oh.
I must have bumped the Google Assistant voice thing. Okay.
Well, the spirits in the certain
Ooh, I
place.
don't understand. Okay, so you're both groups are going to do both projects. It's just that you aren't there yet. Okay, this side of the room is going to start with the thing on the front side of the page. And the front side of the page is a set of, you are trying to figure out which of 2 games is a better deal for you. They give you 2 choices. One's a dartboard, and one's a dice rolling game. And the dartboard gives you a certain amount of money if you hit the dartboard, a certain amount of money if you miss the dartboard, or whatever. Figure out, hey, wait a minute, I'm losing money on that game, or I'm making money on that. And so you're going to figure out the expected value of playing the dart game, and you're going to figure out the expected value of the dice game. Which one's the better deal? Okay? The dartboard game, by the way, think about it this way. They give you, the dartboard is mounted on something that's like this big. Let's just say it's 10 inches on this side and 10 inches on that side. And the dartboard is this thing, and let's just say it has like a 4-inch radius. Okay. Well, wait a minute. You can figure out the area of the dartboard, and you can figure out the area of the whole wall or whatever. Okay? The probability that you hit the dartboard is, its area over the whole area. Does that make sense? It's kind of a Venn diagram type thing. All right, we haven't done quite like that, but I think you'll be good with it. So this group is going to start out trying to figure out, and I want you guys to work together and talk about it. We're going to mingle and all that kind of stuff. Which of those 2 games is the better deal? A useful survival skill if you ever find yourself in, say, Vegas, right? Where there are games with different deals. Meanwhile, the other side of the page is asking you about games. This group is going to get together and come up with a game. what's a good game that the house still wins? What did that mean? That means the expected value for the player is negative, right? So like, for example, if I had made the game outside in the hall, for $2, you can play my game. I'll let you throw a dice. You land on beige, I'll give you $1. You land on brown, you'll get $2. And if you land on green, you get $5.
Are we allowed to do this thing like what casinos do where it's like rigged?
Well, that kind of is rigged though, right? Because look, here's the deal. If it costs you $2 to play and your expected outcome is $1 2/3, $1.66, you're gonna lose, right? I mean, don't get me wrong. Some people I'm gonna be paying out $5 to, but if this would be a good fundraiser, right? I mean, everybody who rolls, I know on average I'd be making 33 cents, right? Because if they paid me $2 to play and they're only averaging getting back $1.67, I'm making 33 cents off of them, right? So the other group is going to do this. I want you to come up with a game. Again, the instructions are a little bit more clear here. Again, I got this off of that MEI or whatever website of like a game. It's a pre-made finite math probability learning activities. That's why it says something about Mr. McCarthy. You're supposed to replace that name with your name, but I forgot to do that before, right? Anyway, you're going to think through and come up with that game. Dice, cards, whatever. But the house needs to win. Okay? And it needs to be a good game. Like, it seems like that would be a fun thing to do. Like, throwing, you know what I'm saying? Like, here's the game. Give me $5. You just lost $5. That's not a good game. Okay?
It's not a good game.
That's not a good game. This is, give me $5 and we're going to draw a card. Okay? What probability? Yeah, and if you get a heart, I'll give you $5. If you get a diamond, I'll give you $4. And if you get okay? But you want to make it so the house wins. Okay? So you come up with a game as a group, and then after a few, maybe 10 minutes or so, we'll switch. Okay? Okay? As to which groups are doing what. All right, so you guys start figuring out which is the better deal in the two games. You start figuring out a game that the house is going to win.
Give me
I'm not good.
And surprise, and Shaquille O'Neal said, I don't know, who's the basketball player?
Game two.
I think game 2 is definitely the better deal. Because the chances that you're gonna do all tails and you're paying her $50, that's really it.
Charade was like $35.
And
And
then what, you
But
get
then
a
the
professional
probability of you
mind.
missing the mark
And you get
completely tomorrow.
$30.
Okay, but how do you bring it to where is it like
I don't
it's
think you
only
can.
abstract
Maybe you should put it dark.
Is it like only abstract
But
concepts?
planeswalker, I
Or
would
like
get
the
coin
house
coming
plays,
in.
it's like
And then
you have
it's
to
if there's a professional
describe
card player, I would
I
put
feel
that
like
on
that
the
would
point.
be wrong.
You can sign on, do whatever you want
Math
with
for
it.
probability.
No,
I should flip it.
no, I think like
Well,
cards,
There is a 3/5 chance. There's a 3/5 chance of losing and a 2/5 chance of
It's
winning.
not something you could really test. I mean,
What would that look like on this thing? It's like, this is a lot more like.
So we're saying this one's better than
And then this
like,
one.
so this is a 5% chance of missing the book of the
okay.
and where do you get that from?
Actually, I think game 1 forward that we could fit. Not really.
No.
It's something we do all the time. I mean, like, we could, there's like,
And there's no way of like how the actual chances for it.
They are the exact
it's
same.
like, you have
False.
14 cards in a suit and then you have 21
Yes.
trumps.
There's some
So you could have so many cards.
They're useless.
Yeah, right. And it's like you can draw wands, swords, cups, pens. So you like, you can draw out of those and then there's a total.
You okay?
What's the question?
You okay?
Trump.
You're actually pretty good at flipping
Like
coins.
you pay $5 to play. If
How can you be good at flipping
draw a
coins?
Trump,
What?
you get $10.
You're pretty good at
And then it's like you
at
can
doing
just
this?
so that's like the same thing he was saying. Like they could set up different cards because then it's creative.
So can we agree it's the point game?
Or how will we do more? You conjuring spirit in here.
Yeah, we have an occult casino, you win the $100 million prize if you can summon a demon in the world of war.
Then you get $10 if
get $10. And slowly, you get $100 million if you conjure, because they get that much if you can stop.
I would go home and finish the day.
Stuff. It's like, yeah, man, it's not that problem.
Usually go home and sleep.
Cool.
You have
Guess what?
marbles.
We figured out
marbles.
Okay.
And then
You have?
like
'Cause I haven't.
5 blue.
Tell me what you
and
think.
like
What you
3
think?
red.
We think it's the coin
and
flipping game.
2
Because
white.
the
And then
odds,
if you
I
get white,
personally
we'll
think that the
pay you
odds
like
of getting all
$10, but
four
if you
coins
get
being
red,
tails
you get
are
like
less
$5,
likely
and if you get
than
what,
the odds of
blue,
you missing
you
the
get
board.
$1, but you have to pay like $5.
But
No, or like
Okay,
$4.
so you didn't actually
But the
figure out the
trick is
expectation.
that
You just sort of did it with an
most-
intuition.
most of
The way
yes.
that
And
these
if
are
you
set,
like,
the way that the odds
if
are
you
set
draw black,
Yep.
because it's free to play, if you draw a black marble,
an equal chance of
you
having
can lose $1.
the same outcome, but
And it says
the trick
like your
is, the
chance
trick
are
is that I
zero.
think what we should
So
do
maybe
is
you
we should, like,
shouldn't.
find a
So
way
you're saying
to-
you have a 5% chance of missing the
I think
board
right.
completely.
I think there
And
should
if
be
you miss
like,
the board
I think there should be
completely,
like 30 marbles.
you
in
pay
black,
$50.
And it's like most
If
of
you hit the
blacks
board
and
but miss the
blues, and
circle,
you have like
so then you pay
Okay,
10.
we'll go with 100.
And then if you hit inside the circle, but not the bullseye, you pay 10. She pays you 10. And if you hit the bullseye, she pays you 50.
Yeah, and then with the other one,
So how
you're
many
actually pretty good at flipping coins.
Yeah, I don't understand what that even means, but that's kind of funny. All right.
for this
35.
whole thing, it's like-
Yeah,
No,
35.
25. Hold on, I'm gonna see.
So,
Okay,
That's
so
already better than.
should we do 20?
So game 2 looks to me like a binomial probability
Okay.
thing.
So how much do we want to spend?
Because it kind of seems
not
like with
being
some of these,
able to
like this
buy,
one
that's
could be better than when paying
Well,
$5 to be
everyone
paying
can
better
see
than the
it
other one
very,
when you
very
pay for like
obvious.
$10.
But
Okay.
you go because there's the chance you'll win.
Okay, so you went for
much is
more of an
that?
intuition
Like,
on
you
it
wanted to
rather
do
than
a
actually like doing the
dollar,
math.
you lose
right?
money,
Okay.
it should.
But we will eventually do the math, but I'm just curious. So, okay, so but you can understand how you would have gotten this for the game of darts, right? You would have the probability, you find the probability of missing the board completely, which is 5%, right? And you'd find out the probability of hitting the board but missing the circle. We'd have to do that with those areas, right? And then we'd have to do the same thing for each of those. We make sure that all these probabilities add up to 1, because you're either gonna miss the board, hit the board, hit the circle, or hit the bullseye, right? And then we would just add them up by each of the outcomes, right? This one's harder because of the, it's got that binomial stuff in it. Okay, so I kind of can understand that that might be,
Red and yellow.
I mean, that's not a simple thing. This is more like a homework problem.
So
that
like
second
blue, I think we
Okay.
should have like the next highest number.
All right,
So like.
I want you guys to wrap up your game in like another minute or so, okay, so we can swap.
Okay, well, we're still trying to figure this out.
Okay, I'm in,
Okay, so 13
What?
marbles.
yeah, why don't you guys go ahead and start that? What am I thinking? Of course, it's not like you guys are actually gonna swap places. So now you're gonna start thinking about how to make a game
And it's like $1.
that is not just I'm taking $5 from you,
And then.
Okay.
but the probability that the house will still win.
You want to do the bottle flipping game?
Nope.
And it's like,
So,
we have 20.
I was thinking,
In
you
my
had
own
dice or something?
home.
No, it's boring.
Game not really hear that, you're like,
Wow!
We don't have
Oh,
any left.
38.
Here you can like beer pong. I'm
I
really
think
not
we
beer.
should
Can
have
we do it
10
throwing a bug away?
for $5.
Throwing a book at Luke.
We should get
If you hit
gotta
him.
die a little level.
Oh, like a little side of this.
How about this?
Two side pieces.
You have an idea?
Let's make it back incorporated, so what's
The card game.
No.
dude at this point or no? How about this? Let's do Uno cards.
It's like,
For every 1 to 3 you get, for every one that you draw. Okay, so the game is like you just take cards and whichever one it is, and like someone gets money, someone gets money. So like for every 1 to like 5
For what? For the.
Scratch that.
you get like.
How about,
That's what the game is. You can just make it like simple and have
Can we
it.
just do the,
Yeah, so you know how we just
The
did
card-
it?
how
about
and
this? You
found
get-
out
you
the
get a
expected
balloon.
value was like the 30 over 8.
If you can.
listen to me.
Okay, so we're.
You get a balloon.
Yeah, so
And
we,
if
so we
you
find
keep
the
it in the
expected
air
value, so then you
for
charge
longer than 30
more
minutes,
than
you get
what we
$50.
charge to play
But
the
if you
game.
drop it
Longer
before
than
30
30
minutes,
minutes.
if you drop it before 30
Let's
minutes,
make it like 5 instead of 30.
that's so easy.
Exactly.
can we just do something with actual bug?
Yeah, let's just do it with cards, I got you.
It's,
So you get a haircut.
No. Your mom dies.
Jeez.
So let's just do my glow card game, okay? For every
okay,
1
no,
to
so
5.
it's like, it's gonna be like, whenever you have, was it red and black game, and there's a green, so we get into like red and black. And then
What does it mean when it says expected
For
payout for
everyone
casino
to-
on a one-player
okay,
bid?
the game
it's
is.
predictable.
That means just when one player, that just means when one person plays.
So this
But it
is
says
what
$1.
So
What if we
you
have
get
a
cards,
$1?
let's say 1 through 5, we have to.
Oh, does it actually have more? I'm not really all that worried about like.
Get 6 to 10, then I will give
I'm
you-
using the problem here as
and
an,
then
as
if
an
it's a
inspiration.
queen
I mean, you don't have to
or
necessarily answer all these little
I'm only
questions.
giving you $5.
Okay.
You-
I'm not
I
that
would-
bogged down. I'm curious as to what your
After
game
eight,
is and how you know that it's gonna
You can
be
do it how,
Or
benefiting
it
the
predicts
house.
which one
go
you
to
get.
the doctor.
Okay, the actual answering every single
The
thing.
chance of getting, no, not even.
What do you wanna do?
I was gonna say like, if they predict whichever card they draw, and if they don't draw that, then they have to pay you the first. That's good too. That's
Whatever.
yours is easier.
So you pick someone up, throw them straight out.
So how much do you want to say
What's
they
the
pay?
probability of
Like
that?
$4?
Okay, I'm gonna put
And then $10.
2 players,
What are we doing?
1 deck of cards.
I got 1.935 is my expected value.
What?
What are we doing?
Look, I don't know what you were saying, Northern, about getting a haircut.
I was gonna.
Oh, it's lose, that's why.
We could do it like an arcade game.
I didn't realize
It's not
that.
boring.
That's okay, that's okay.
You know how like the games where you gotta
Okay,
get
so
through the hole?
we're getting about
And
$2
if you lose,
back.
it costs $2,
Call,
but if
call it
you
as
win,
all
you
I
win
for
like
every
300.
time. So
It's
like,
insanely hard, you want to win every time you try. It's great. So you win.
5.3 out of 15, I paid like to
1 through 5,
so we paid them in
give
customers,
player
like,
1
$8. But like, okay, but
$20.
Ow. What do you?
That's a lot of money.
What is?
even if we did like
$40,
$3
for what?
though, like.
6 through
Okay, so
10.
I'm afraid that
So we,
the apples are not like outrageous price because there's only 10.
No, you can decide
break
if,
even.
okay, you can decide which player 1 and player 2.
So, yeah, I think $3.
Yes, Luke?
Are we doing cards?
Yes.
So 1 through 5, you just get money if you draw it.
Yeah.
Simple.
we go to like red and black.
Yeah, we use them with the red and black too.
$5.
Or give
You want to be the best salesman ever.
Building game.
Did you buy something off my recommendation earlier?
No.
What if it was with computers?
Probably not. Depends what you're talking about.
Is there any reason why you're
Just like-
this?
I don't know, I suck today. Alright,
Stop looking at me. I don't like how you guys threw away my suggestions.
Because all you said was, what if you got a haircut and not
Then
the
you guys cut me off. You need the rest of my idea.
How much does this cost to play?
You have the deck with two friends, you all work together,
No, this is, okay, I figured out how to make the game work, okay?
and every time.
For every- okay, so-
It has to be.
One person is holding the deck, one person is drawing out, okay? So if one person is decided to be player 1, one person is decided to be player 2. So let's say the person holding the deck is player 1. So I'm drawing, and then if I draw a 1 to 5, I have to give that player 1 $20, or I do a dare from that player. And truth from the other player. And then if you draw an ace or a king, you either give $5 to the other player, or you try again, but the money doubles. And then the same thing for the jack and queen, you give player one $5, or try again, but the money doubles.
You really just added truth or dare.
Yeah. And then I double things for ace and king. That's our game.
Truth or dare. It's extreme though. That's stuff you don't want to answer.
Yes. Extreme.
But don't put you just put extreme.
Extreme 52 pickup. I don't know. How could we can make it one in, right?
Why do you have money doubles, like, whatever?
Instead of being $5, it'd be $10.
So it'd be like 40.
What if the person you're doing with is a magician?
Let's figure out the.
I wonder if magicians are really good. I think they have cameras.
I will be controlling. I work 4 to 12.
You never get off the board well.
I
But
can
technically
sometimes
the
get off
board
like
is the
11:30
10 by 10.
and it was a
It's a
Saturday
10 by
night.
10 square dartboard.
Right, so if you miss the board, you pay her.
The early vote.
But if you hit the board and don't get the circles, you pay
I'm
her
gonna just say
10.
that right now.
Okay. But like, what's the out of? Because I don't know what the percentage of the wall is. Because technically the 10 by 10 is the board.
Probably like two.
Right,
Leave
so
this like
I
percentage.
don't know, so now we're
Okay,
just.
if I drive it out, because I don't know if I can fucking drive myself. If I drive myself.
I found out.
Okay, so you know
The dartboard's
Oh, from the
100, the
wedding?
circle is 50, and then within it is the radius of the 1-1 is the big 1-1-4.
Okay, let's see, you have a
Either way.
5%
Am I good
chance
enough?
of missing the board completely,
I wish I
and a
could.
95% chance of hitting similar numbers, so we know that.
I feel like it's not just on the board, but I don't understand it if you don't hit the board.
Or I can see if I can switch shifts or something.
5%.
How?
I've done it before.
Right down there.
Okay.
It's over again.
I do have like 8 to 4. I'm gonna do something like that. Cause I think 2:30 to 5.
That's a nice shift, 10:30 to 5.
Yeah.
That's a nice shift.
But I'd be getting that instead of my 4 to 12. Actually, I'm gonna work 4 to 12. Cause that's how the hours. We need that.
It's only an hour and a half.
Yeah. And that's like a big difference. And I couldn't even switch with anyone even if I wanted. I could see if Jaden wanted to switch.
Have you guys started, Malia and MJ and stuff, have you guys started the other side of the problem sheet?
Yeah.
Okay, great. All right. Okay.
Are you doing it properly?
I'm trying to remember, what did you guys say you thought the odds, which game did you thought think was better?
Coin flipping?
You thought coin flipping.
Not just because.
Because they're a pretty good coin flipper.
Because you have.
Because they're a pretty good coin flipper. I thought that was funny. I wonder how that works.
There's one problem
You
because
have a higher chance.
they're not
of
like-
what you want.
they get, wait, didn't say how often they would get the side they wanted.
It's like, you have a 5%
Oh, yeah,
chance of
the
missing
deep
the board completely,
Never
and
mind.
then 95% chance of just hitting some.
Actually, working through the math over here, you guys, is actually kind of cumbersome. So I would settle for like an intuition argument as to why you think one game is an
See, I
See, here's the
think-
deal. A homework problem, it would actually, like we had time and you could come talk to me, you could write to me. Those problems are a little bit on the hard side. I'm gonna actually show you on a spreadsheet how to solve those real quick, okay?
So
But I'd settle for an intuition as to which of the two is the better game to play.
I say coins because, like, one, you have 4 tosses, and this one, you can only throw 1 dart, and you don't, and your tarot payoff is about the same, but like, you have a higher chance of getting what you want.
I'm saying like for this one, if you do have to pay, it's like, you have to pay her off.
Well, no, you have to pay the same amount,
Yeah.
like, if you miss the
But you stop, so if you stop.
right.
Okay, ready, now drive. Give me something to get ready.
Second story,
So it's going, and we practice every day.
What is that?
and then the second place.
Tonight, it's I'm going to sing tonight. I'll be off at
'Other thing,
Someone just gave me my knowledge. They're already turning 18. I'm buying 21. I think I'm gonna cry if I don't win. That's what it's called. Get rich quick.
Yeah, I don't actually do it.
That's a very
Get stacks.
Okay.
I don't like this. And then
Tell you what, let's go ahead. In case, by the way, you want to right away, go ahead and write down the assignment that is for today. If you need me to, I'll post it on. I've been kind of lazy lately about posting things on It's Learning because I check and most of the time the views is 0. And so I don't think very many people go there to look for the assignment. It's
Can you post the assignment? Because I had to text like so many people trying to.
Oh, okay. Well, you can always text me too.
But this was like at 11 o'clock.
Oh, then you're in trouble. Yeah. Okay. Yeah. That's no problem. Yeah, I can take care of that. Anyway, I kind of got in a bad habit about that. So, okay. I am interested in hearing about these cutthroat games you guys came up with. Lisa, Andrew, and Luke, tell me about your cutthroat game that you've invented.
Okay, so at the beginning of the game, you decide who is player 1 and who is player 2. Okay, so all you need is a deck of cards. One person is holding the deck of cards, and the other person is drawing from the deck of cards. Okay, so if you draw a 1 to 5, you give player 1 $20, or if you do a dare from the other player.
Ooh.
Okay, so then, so either instead of giving player 1 $20, you could take a dare from player 1.
Okay.
Or you could then, if you draw a 6 to 10, you either give player 2 $20, or you take a truth from player 2.
Okay.
And then if you get an ace or a king,
Oh my gosh.
you
Okay.
give $5 to player 2, or try again, but then the money doubles.
Okay.
So you can try not to get an ace or a king, but if it does happen, then you have to give the person $10 to the
And tell me how you decided that that is rigged against the players.
How is that rigged against
Yeah.
the
Okay, that's okay. I like the game that you invented. Here's the deal though. So, okay, so what we would want to do, I like the game, and I like the fact that you came up with, and it's got these conditions in it. Because of course, real games usually do. Like, you can do things, like, for example, when you play blackjack at the casino, you can, what do you got? You can split the hand, I can't even think what that's called, you know, and stuff like that. There's usually conditions, or you can double down on your bet, or something like that, okay? And so, the idea that you put conditions in there is what kind of makes the game complicated and hard for people just to figure out in their head as they're playing, right?
See, and the conditions for this are 50-50. Like, you could either get like 1 to 5, the chance of getting those is as likely as getting like 6 to 10.
Yeah.
And the same thing with like the aces, the kings.
Those dares in there are the tricky part.
That's the fun part.
Yeah. Okay. Tell me about your cutthroat game.
Okay, so we have a game where it's like you have a bag filled with 50 marbles.
Okay.
25 are black, 13 are blue, 10 are red, and 2 are yellow.
Okay.
So if you draw black, you lose 25 cents.
Okay.
If you draw a blue, you win $1. If you draw a red, you get 5. And if you draw a yellow, you win 20.
This sounds like exactly like the kind of things that are in the homework set. Okay.
Yeah.
And so, did you actually do the expectation and figure out like what the chances of like what should you expect each time you do a draw?
Well, you'd expect, yeah, $1 like 90.
Is what you lose or make?
Is what you would make
The other
off
person makes.
Okay.
It's like the total expected value. As long as you're charging if you charge like $3, like that's just how much we did like the 80 quid.
Sure. It's all
so-
going to come down to what you charge.
Right, and if
Yeah.
we pay
If
if
you-
we
yeah.
did a $1 player bid, we would only be making about 94 cents. So that was like no. So three is like enough to like make a profit, like a substantial
Sure.
profit, but without feeling
Sure.
like you're being charged too much because you don't know like the play unless
they're one of those people that they sit and they watch the casino games and figure out the patterns and stuff. Most of your, you know, players aren't going to know that there's only 2 yellow, which you win $20 for. So.
It'd have to be disclosed. I mean, like all Vegas type games, they have to tell you what's in there, right? You can't not know, but.
But you can kind of not tell them the numbers.
Yeah, well, that don't mean they're making the best decision when there's also a comped buffet and beer, right? You know what I'm saying? Yeah. Okay, cool. I like those games too, and I like the fact that you tied it back to, it depends on what you charge them to play, right? Because that's right. That's going to make a huge difference. All casino type games are biased in favor of the house, of course. They're not a charity, right? Most of the games have surprisingly bad outcomes, okay? Not as bad as like lottery or something like that. But all of them, if you bet $1, you're going to lose that $1. You know, you can expect to lose. And some of them are pretty close. Like, you know, your net effect is you lose a penny on every $1. Not that there's many dollar bets, but you know what I'm saying. But when over the course of a year, there's 1 billion hands of blackjack played, and on average they've lost a penny, they just made $10 million, right, over the course of the year. And so they know the rules. By the way, I believe the best game to play is roulette. Because roulette is actually really close to break even. It's still negative against you, but nowhere near as much as like poker.
Is that like 50-50?
It's really close. On roulette, like the basic bet is just to bet on, like the basic bet in roulette is either red or black, right? You spin the wheel, they throw the little ball, it bounces around, and there's like 36 little spots around the edge, half of which are black and half of which are red. But there's 1 green, maybe 2 green spots along the way. That you don't get money either way then, okay? And so it is slightly biased against you. Sometimes it lands on the green and they just keep your money, right?
That'd be unfortunate.
Yeah, I know it is. Or like you can bet on odd or even, but there's 2 spots on the board that are neither odd nor even.
And then you can like bet on a specific.
Or you can bet on a single number, and those odds are slightly against you too. But roulette is actually the closest to a fair game. The rest of them are all much more biased against the house. All right, I want to talk about the problems on the front part of the page here, because they were hard, but they were not so much hard, they were just hard to do like in a quick little classroom situation. To talk about this dartboard game, the dartboard game said you have a 5% of missing the board altogether, and then you pay them $50. So there's a 5% chance you're going to have a missed thing. Now, there was a chance you were going to hit the board but not the circle. Okay, so that is a little hard to compute, but there was okay, so it's the 95% chance you at least hit the board, times how much of the area is board but not circle. So it's this 100, and then it's subtracting off the part that is this area around the circle, and I worked it out. And similarly, there was an amount of money you got if you hit the circle but not the bullseye, and I worked out the math. Again, it's just geometry and stuff. It's like thinking about this as a Venn diagram or something like that. Anyway, I worked them all through within the area of the bullseye. But these are all clumsy calculations, and I hate that. I don't want to mess with that. So I made a spreadsheet because that's just the kind of guy I am. And because I knew already the second problem that involved those flips of the coin were going to be, I mean, that's a binomial probability thing, and I don't want to deal with that. Okay? I mean, I don't want to be doing all that math by hand and stuff like that. So I knew I needed a spreadsheet anyway. All right, so I went over here and I made a spreadsheet, which if you want, I'll be glad to share with you if you're curious. All right, so I computed each of those probabilities. Let's zoom this thing out a little bit. View, zoom. Let's make it a little bigger. Okay, so one possibility is you miss the board. That is a 5% probability, and it is you lose $50. If you hit the board but not the circle, it was all that geometry I did up there, but that works out to the probability that you hit the board but missed the circle, and you lose $10. You hit the circle but not the bullseye. Again, it was a bunch of geometry. You had to know the area of the circle and all that crap. But that was its probability when I did the equation, and there it is. And then that's the probability of hitting the bullseye, and that's the amount of money you get. I double-checked myself to make sure I did this right by adding up all the probabilities, and they did come to 1. Okay, I'll even hover over the equation I used right there. See, it's just the sum, equals sum of these cells. Made sure it added up to 1, and then I computed the expectation, or the expected value, which was just this times this, plus this times this, plus this times this, plus this times this. right? The probability of an outcome times the value you give that outcome, plus the probability of the next outcome times the probability times the value you give that outcome, and I ended up with negative 1.26 basically. Meaning each time you play this game, you expect to lose $1.26. So like this might be a good game for like at a church raffle or something like that. You're making money. I mean, it's a game, right? I won't show you how I did it. Oh, I'll show you just in case, because when I share this with you, so you can see it. There is a nifty little, there's a shortcut called equal sum product. That is how I did that, in case Mr. King never showed you. But sum product means, take these numbers and multiply them with these guys and then add it up. And I happen to know that works, so I did it. Anyway, but you wouldn't have to. You could have done it that way. Now let's play the coins game. I don't understand how, but somehow or other you're good at throwing heads. Which is ridiculous, but whatever. And you had a 55% chance at any given time of throwing heads, and there's 4 coins. And it said, okay, if you throw no heads, you lose 50 bucks. If you throw 1 head, you lose 10 bucks. If you throw 2 heads, you lose 5 bucks. If you throw 3, you get 10, and if you throw 4, you get 50. All right, this is a binomial probability problem because you have a series of independent events that are either successes or failures with some probability associated with success and some probability associated with failure. That's a classic example of a binomial theoretical problem, and you just did that on this homework set. And so I had to work it through. I had to figure out the combinations of 4 things taken 0 at a time, combinations of whatever, and I came up with these numbers, and wait a minute, I thought I'd show you something, in case you have any more examples of that. It turns out there is a function in Google that can do it. Equals combin. Equals combin, n comma x works just fine. I didn't tell you that earlier because I wanted you to know how to do it. I wanted you to do it the hard way. But equals combin works, and I couldn't stop you from Googling it if you wanted to try. By the way, I bet you're guessing that there's also something called equals permute. Anyway, all right, so I got those. I had to compute the probabilities of each of those things happening. That was a combination of n things taken r at a time times p to the x times 1 minus p to the n minus x power and all that kind of stuff. It's clumsy. It's what you did last time. Here's those probabilities. Just to make sure I did it right, I added them up. And okay, they add up to 1. Because those are the only possibilities. I can't throw 5 heads out of 4 coins. Or anything else. Those are exhaustive. They get it all. And then I did the expectation by taking this probability times this outcome, this probability times this outcome, and so on. And it turns out I get positive 0.68. Meaning that I expect that I'll end up with $1.68 each time I throw the coin. Okay? I'll never exactly get $1.68. Sometimes I lose 50 bucks. Sometimes I win 50 bucks. But I expect to win $1.68 over the long run. Hey, how come this worked out positive? Kind of looks like a sucky game, doesn't it? I mean, throwing 2 of them being heads, you still lose money. Why does this work out? Why is this guy making money?
Because you're really good at it.
Because you're damn good at making heads on the coin. If I go over here and just change the problem real quick. Let's say this guy only has a 50% chance of getting a coin. Notice the numbers all changed. Now he expects to lose $1.87. Okay? It's only because he's good at this, supposedly, that he wins. All right, with the remaining 6 minutes that we have, there is an exit ticket. Go ahead and, I haven't looked at it recently. Is it a hard exit ticket or an easy one? Let me go look real quick. If it's a hard one, we might make it so you don't have to get it to me until like after lunch.
I think it is a hard one.
Is it?
No, it's only 3 questions.
It's only 3 questions.
Fine.
Oh, but that second one is hard. You know what? Nope. You can get this to me. You can do it right now if you want. But if you get it to me by 1 o'clock, I'm okay with it. Because I think problems 2 and 3 take a little bit of paper. Okay? Alright, so if you want to do 2 and 3 and get it to me, do you want a text or anything like that reminding you?
Yes.
That would be nice.
Okay.
Can you roll the board? I didn't write down the homework.
Okay. Yes, hold on. Yeah, problems 2 and 3 both require a little bit of paper. And so they might take a little bit more time. Alright, I am going to take the remaining 6 minutes of our class and chase some of this stuff back up to the front office.